Wait, hold on. Okay, I can actually speak. Yeah, yeah, I can speak. I don't have window capture. I don't even have game capture, but I'll have a little bit of desktop audio in the background. But I'm not really sure what else I'm gonna do. I'm grinding. I'm grinding 4-star bamboo. Oh, oh, that's not so bad. Um, what was I about to do? Yeah, so I have to do. I have to study for stuff tomorrow, but Daisy wanted me to stream, so I mean, I have a chance to do something here. Okay. Okay, this would be quite interesting. I haven't done this particular exam before. But if I really need to, I guess what I could do is just take screen snips of everything and then copy paste problems onto my screen. If I'm allowed to do that. Yeah. So copy paste problems onto my screen and then start working on them. So I'll do 2 at a time just so it's easier for me to do. All right, and should be good. Hi Chase, welcome to the stream. I'm actually a little bit surprised that you guys are watching. I'm going to be watching this. This is going to be quite interesting. I'll scroll down. I'll put it here. If it will paste, there we go. Now, I don't think I'll have too much music in the background. I mean, if I do, it'll probably be from Clash Royale, and that will be about it. Speaking of which, if I mute my computer, I want to see how that sounds from my TV back here. I think ideally, if I'm not going to be checking my phone that much, I need to at least have stream up on TV. So if I miss a comment or anything, I can just easily just read it. Hi, Fan Fusion. I don't think I've seen you before. Welcome to stream. Drawing or listening to this? Okay. 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 I have my first problem here. This shouldn't be too bad. Although, I'm trying to remember what to do here. I think my pen is too large. If I start... No, it's not actually. Okay, that's okay. It's like fine. You can run with 5 pixels. Alright, part A. Okay, I have to remember I'm using a mouse, so I don't have the best dexterity over here. Equilibrium solutions, draw. This should be pretty easy to do. I have this function. I could factor out this y. So what I'll do, I could just factor out the y here. I'll actually draw arrows just to make it easier for people to see stuff. And for myself, so I understand what I'm doing. Alright, just factor out a y here. Y squared, and then this would be 2 minus y in here. To get this to be at equilibrium, I have 2 options. So from this, I have to make this 0. Then 2. But just to show that, what I could do is just add y to the other side. Actually, no, this is actually pretty easy to show, but I could just do the direct showing here of what it should be. Just to prove it. There we go. I can erase this now. I prefer a larger eraser. There we go. Just to prove it. For this, now that I know this, and I know this is equal to 0, I have equilibrium points 0 and y is equal to 2. So now I have to draw a graph for that. I'll use blue for it. Increase pixel size a little bit. Okay, and now actually this is a little bit off center. This is more on center, but just can't seem to get it right. There we go. And then what I want is I have 2 here, and then this is one boundary point, generally along this line. And then this is my secondary boundary point. Okay. And then I have to find what the trend of solutions is here. In the previous stream, I had this height to be a lot larger, and I still got everything to fit in, but I guess to make it easier for myself, I just have it be a wide image. I don't know, have a sub though. You don't know why you're here? I mean, you just kind of wanted to watch me, so I imagine that's why. I don't know the full reason. In this case, I have to test, I think, 3 solutions, so what I'm going to do, I need to test y when it's greater than 2, when it's between 2 and 0, and when it's less than 0. So that's what I have to do. I'll turn this down a little bit. Okay, when y is less than 0. Yeah, the size here actually isn't too great, and I'm making my letters very big, so it's going to be difficult for me to see anything. At least in this case, I know from this function here, if I were to plug in 3, for example, this would become 27. Although, hold on. This become, if I put 3 in here, I get 9 times 2 is 18. This becomes 27, so I got a negative number here. So in this circumstance, I would get a negative sign here due to what I just found over on this side. If I were to plug in, actually, it's easier to plug it in here, to be fair. This is very easy to plug in. If it's, whatchamacallit, if it's between 0 and 2, then this is positive and this is positive, so this would also be positive here. This is the easy stuff, though. And then if it's below 1 with a negative sign, then this does not turn negative. It squares itself, and then this is still positive. So I still have a positive point here. So if I'm going to draw the directional field, it looks something like this. Yeah, so I'd still get a point of convergence here. It's just not stable. Whereas on this leeward side, I would get a decreasing motion towards this plane, which is not so bad. Yeah, so this is generally what it should look like. Part B of this question is plotting a graph of y0 is greater than 2 between these, and okay. So a typical solution, if y0 is less than 0, I'll get a blue color here. Then if it's just like, let's say it's here, then in general, what should happen is I should get a function, not like that. I should get a function that comes up through here and plateaus there. If I have one that's between 0 and 2, like it's here, then it should start here, rise up, and then cut like that. Well, I should probably use a different color just to make it easier to see it. It should start here, rise up, and then plateau. And then here, it would just start up here and then start plateauing, but never actually hit this line. So that's question 1 done. Move on to question 2. Find explicit solution y of t for the following initial value problem. I believe from what I remember, trying to remember anyway, I don't have for B, I don't think I could just separate that directly. I don't think I can do that. Just looking at it, I don't have that ability to just separate. Although I think this may actually just be a C1 problem from my perspective. That might just be what it is. And I have to factor this out. I'll see. But that seems to be what I have now. It's a little bit difficult, but I can try. For this top portion here, t over y, and then I have this here. This looks like integration factor. From my understanding, this portion here, I might need to bring up another one of my streams just to make sure I actually know what I'm talking about. Okay, take this t down. Well, divide it out, rather. Take it divided out of all these terms, and it should get this. Okay, plus, in this case, I have 2t plus 1. And that will be all over divided by t. Which, if I divide each term by t, it'll be a little bit different. But I don't want to have two different terms, because that would not be very beneficial for me. Bigger t, 1 over ty is equal to e negative 2 t over t. Now, this I think will lead to not partial fractions, integration by parts if I look at it. Now I can work with this. My p of t situation, at least in this circumstance, would be this right here. Actually, I am looking. You can't factor out t from this, so never mind. In this case, I'd have, I believe it would be this one. Let's make that look a little bit better. I think it would be this. I can hear myself, right? Yeah, there we go. Plus 1 over t. So this entire function. And now, if I need to get that into the denominator, I need to find a way to integrate this. Now, as far as I know, 2t times 1 would just give me 1. I don't actually have that. Now I have to actually think a little bit more. I have to think a little bit more about this one. Because if I'm trying to take t out of here, then I would get 2 plus 1 over t. But this t on the bottom does not necessarily allow me to do that, per se. Although, to be fair, I could probably consider a different way. Because if I... Actually, no. I could think of it a different way. Because if I'm trying to integrate by t, then times this, I have two separate integrals. But I'm not sure if that's something that you're allowed to do. Because I don't remember. I don't think that's something I can just do. From my experience. Have to do a quick check of the solution here just to make sure it's actually correct. But from my memory, I don't believe you can do that. A quick check. Not the entire solution, but the first part of it. No, you can do that, okay. No, you can integrate both of these separately and they can still work. Okay, never mind. I was not thinking correctly. Okay. So you can work with this. So, okay. Now it just becomes 2 plus 1 over 2. That's what I was thinking. I didn't know if I could just directly do that. What I need to do now is I need to integrate this function. So I need to set this over in e integral. And then integral of 2 plus 1 over t. And then dt here. Okay. So this should be 2t ln t plus ln t. From at least from how I remember this, just adding these together, I would have 2 e's here. This ln t is not going to break this. I'll check each problem at the end just to make sure I'm doing it correctly. Because I have that solution available to me. But I believe this is what it would be. And then this would just break up into times e. And this would just become t. So in this case, I get t. actually bring this down. I would simplify this into t e 2t. And now if I'm trying to go over here to get y again, it would be equal to u, but then I can bring this over. This would be on the bottom. See? And then, yes, because that works because I have this function right here. So, mouse, don't mess me up here. I can bring this function inside. Well, integral of this function. And then it has to be times g of t, which is this. It's e negative 2t. Here. Okay, these should cancel. Major reason being that this here, if you're adding a negative 2t, that's just equivalent to 2t minus 2t. So this would become e of 0 is equal to 1. So at the end, I just simplify this. Integral of t. And then I still have this on the outside. Okay. A little bit of a brain issue earlier, but things are working. So I would get 1/2 t squared here. Plus c. And then I have to multiply it by, all multiplied underneath by this function here. It's equal to y. And now I believe I have a value here, which is this one. So y of 1 is equal to 0. In order for this to work, then this would be e2t. This right here would be, if this is 0, I just thought about this. And the only thing that matters is what's up here. So I'll convert this over. If this is equal to 0, then the only thing that really matters if I multiply like this over, because this will turn to 0, would be this component right here. So all I'm trying to do is set that equal to 0. And in this case, because I have y1 is equal to 0, I just get 1/2 plus c is equal to 0. So then subtract this over. And then I have to get negative 1/2 is equal to c. So the initial value problem simplifies. Make that a little bit better. There we go. Simplifies into, okay. And what I have over here, make that a little bit better. 1/2 t squared minus 1/2. And just draw what's underneath. e2t minus 1/2. And that looks like a plus. I could fix that. It's supposed to be minus. There we go. So that's the first part of this problem done. So this is part A. Part A. And now I have this segment here. 2t squared this. Now I'm thinking personally for this, I need to factor out t in a way. So I could just bring that down here. Actually, this is the bottom of this page, isn't it? Yeah, it's the bottom of this page. I need to make this bigger. Hold on. I need to make this bigger. The height, I need to not at least double it, because I'm writing too big. Make that 1600. Give me a whole lot more space. Yeah. B here should be a little different. Hi Sonic. What's going on? Well, Jero, what's going on? Welcome to stream. Tired after 2 hours. Storm, what's a good weapon? What's a good way to learn a weapon? You have to keep playing the weapon to learn to play the weapon. That's usually what you should be doing. Alright. What was the question again? Is this one? Yeah, 2t squared. Derivative of y It's actually taking a while to actually write this. I'm having frame drops, actually. Maybe because I have too many tabs open. That could be it. I think that might be the reason. What I'll do, I'll actually cut down on the amount of tabs I have open, just to make life easier. Discord being open, I guess, is fine. I think I can handle that. And there we go. Okay. Minus ty cubed plus y cubed. Oh, this is... I believe this turns into a complex number, actually. It should turn into some form of complex number. That should happen. Because just looking at it. Actually, no. No, I'm somewhat thinking about it. This t here doesn't really matter too much because I can't just factor out a y cubed here. I mean, I could, but not really. It wouldn't really be too worth it to do that. Just bring down everything. I was trying to think what I can actually do here. I'm gonna have to do this in less than 3 minutes. I'm gonna have to do this in less than 5 minutes tomorrow, but that should be fine. Okay, it should be equal to 0. And then that's obvious. I'll actually close Discord for now. Just logging out my computer. Ty cubed is equal to 0, and then this is the initial value problem. I'll address this one later. Okay. Okay, Castle Labs just died on me briefly. I don't know why, but it just did. Yeah. I don't know what's happening there. We shouldn't be doing that. Okay, so I'm just looking at it. That's why prime. I would need to get rid of this feature here. That's what I'm thinking. Get rid of this feature, and you could solve for everything else easier. But I don't think it's that simple. Can't be that simple. It has to be a little bit more challenging than that. I'm a little bit stuck here, just considering what I have here. I know this is a derivative of y, but because this is in y cubed format, I don't have a y in this area. But I guess what I could do is use the Pythagorean theorem here, because in terms of coefficients, for the most part, because I can factor this out. If I factor out y cubed, I would get t plus 1 in here. Actually, no, that would be a little incorrect, right? This is a little incorrect. Actually, no, it would not be. I have y cubed in here. It's just subtracted. It would be something like this. Now, the main question is, because it's y cubed, I'm not sure if I can just go directly into the factoring just yet. So at least looking at me, this is not going to be a repeated root scenario. It generally cannot be such a case. Oh, okay. So this is separate. Oh, this is separable. What am I doing? Oh my god. It is separable. Duh. I'm not thinking correctly. That's what the problem is. I'm not thinking. Okay. I'm a little bit slower today. I have to get this over here because I know what this is. But the main question now is, okay, if this is ty cubed plus this, then if I take out a y cubed factor from both of these, I would get negative t actually. So I have negative t minus negative t plus 1. Okay, wait. Actually, I could keep it the way it is. This is actually accurate, and then I could just make this equal to each other. Why is that? I can just port it over. So I could just move this. I could just move the entire function here. And that's pretty easy to do. And that will become a better version of this function. So I'll cross this out because this is harder to read. So it would just turn into, if I were to simplify it, well, don't cross this out actually. Keep that the way it is. You can just move this underneath this derivative and move this over here. So I just get t plus 1 over t squared. That looks more realistic as to what I actually have available for the most part. Yeah, so that looks generally okay. And now I can split that up into two different equations, and this should be fine. And then let's get this y prime under here. Yeah, so that's equal to each other. I can integrate these. So I can set up an integral for both of these. Only difference is that this is dt and this is dy. At least in this case, if I integrate this function, I would pull a 2 out. Divide a 2 out from the top, and this would become negative. So I would get, at least in this case, I would get y squared on the bottom, 2, and then I have 1 on top still. So I have negative 1 over 2y squared on my left side, and then on the right, it would be a little bit easier. I'm tired of fighting, tired of not getting to fight it. Yeah, the season reset. Okay. And then t plus 1 here, t2 squared. Okay, this here would simplify to just 1 over t, 2t. And then I'd still have, well, no, it's not going to simplify directly that way. That would be inaccurate. It's not going to simplify like that. I will here, but then I have to integrate it. So I know this would become the integral of 1 over 2t. Because you can separate fractions. And then the left side is still this here. Alright, so in this case, if I were to do the integral of this function right now, then I believe this is 2t. What had to come before this is that this had to be ln. Because if it was 2t naturally, then it would be 2t on the bottom. Oh, actually, no, never mind. This should just turn to ln 2t. So I have ln 2t here. Help me. And just have ln 2t in this area because derivative of ln to whatever ln to whatever variable here would just be 1 over that variable times the d of whatever of said variable. So ln 2t works here. Whereas for this function, this would just be a negative 1 over 2t. So that would just convert to negative 1 over 2t. Okay, so I have this feature now. One thing I need to do is I need to bring this feature, and you bring this entire feature here over to this side. And then bring this feature. Not the 1. I don't need to bring the 1 over to that side. But I need to bring my y into this current position. So what I'll do is just multiply by 2y squared, and I would get 2y squared on this end. And that's equal to, from my understanding, it would be equal to this. So negative 1 over, I'll use green. use yellow actually. It would just be equal to this function. Trace that out. Natural log of 2t minus 1 over 2t. So these would be equal to each other. I could divide by 2 here and then take a square root of this function. At least from as far as I remember, you can't, since this is the entire function, I imagine it'd be a little bit different. If I divide by 2 though, then this bottom part gets multiplied by 2. So I think just generally with that information in mind that I would eliminate that 2t on the bottom and I just have t there. Oh, I just have negative 1 over t rather. So continue to work on this. Divide by 2. Just get y squared. This would be 2 ln t. But I'll have the entire function multiplied by this. And then it'll be easier to simplify it once I actually get this in here. Okay, so and then if I take a square root of this, I'd get plus or minus technically equal to y 1. That does not change. And then the square root of it's 2 already comes in, so this becomes negative 1 over t. ln 2 ln t 2 ln t 2t minus 1 over t. That should be it from my perspective. Now, at least from what I remember, ow, and he has not scratched so much. I'm gonna start bleeding soon. You're gonna quit Splatoon? Why? Oh my goodness. Okay. Going back though. What am I looking at? I have this, so if I were to plug in. Oh wait, I think I missed something. I'm missing something here. There has to be a plus C underneath here. I missed something. I missed plus C. There's a constant that may come along with this. So I gotta add plus C to all of these. There you go. Okay. Now consider the initial value problem of this. Y1 is equal to 1. So 1 is equal to. Let you move over a little bit. Oh, I don't want to take up that much space. I'm gonna get some more zoom in some places. Did I mess this up? No. I'm just taking too much space. That's what's happening. I'll take up less space next time. Okay. Where am I? I'm here. Let's try to condense on the space here so I can fit in a lot more. 1 is equal to, in my case, 1 over 2 ln t. Well, square root 2 ln t. T minus 1 plus C. Okay. Looking at this, if I want this 1 to equal whatever this is here, I would need this square root here to simplify to 1. So I need a negative 2 ln 2 plus. Okay, actually thinking about it, this, if you assume this is here, if I would square this function, it's not going to matter. 2 ln 2, because that's what I'm looking for, minus 1 plus C. if I minus subtract this over, yes, so subtract this over, well, multiply it plus it, add it over, remember? Then I'd get 2, and I could subtract this. 2 minus 2 ln 2 is equal to c. Now, if I plug that in here, this cancels with this, and then I just get 1, so that works. So my initial value problem, from my analysis, if I can actually draw it here, write it down rather, would just be y is equal to 1 over 2 natural log of 2, t in this case, minus 1 plus, okay, hold on, erase this. Plus 2 minus 2 ln 2. Okay, so that will be that section. As for number 3, it shouldn't take so long. Well, I don't believe it should take too long, but maybe it will. So I'll take 3, and then I'll put in number 4, etc. Math isn't scary. It's the universal language. It's not that scary, to be fair. Is it paste? There we go. Like, being able to see what's on my screen right now requires a lot of math to actually be able to at least even see a stream. This is matrix math, so a bit more advanced than what I'm doing here. So it's very useful. All right, I probably will want to do 4 first, and then get to that's the wrong button, and then get to number 3 up there. 3 will take a little bit longer than this one. All right, so I'm looking for a diff equation with all these different combinations here, so this shouldn't be so bad. Okay, so actually I need to get, where's the pick tool? I don't know if I have one. I can't really move this thing around. There we go. I think this should begin to move, I hope. No, it's not going to move that easily. No, it doesn't do that. Oh my god. I'm a magician, but I can't actually move stuff. Okay. Can you re-add that? Okay, that's fine. Okay, so we'll just ignore that. Okay, so I need a second order equation. All right. Linear. All right. And it's got to be homogeneous. Or homogeneous, for one. So this needs to be second order. Homogeneous equation. I know that this is not going to make it linear. So I need to get rid of that term there. What else? I need to get rid of this term here. This is not multiplied by anything. Considering. So this also needs to be 0, most likely. And then this term can't be too tall. Alright, so should be pretty easy. A equals 0. B equals 0. B is not equal. No, not A equals 0. That's wrong. A minus 1 needs to be equal to 0. So A is equal to 1. I need B to be 0 for this to be linear still. It's B function to be 0, rather. It's equal to 0. So I need B to equal 3. The reason so you can just add this over. It doesn't really matter. For this to be linear, I need this to be, need the exponent on any y to be less than, I think it has to usually be approximately exactly 1. It has to equal 1 for it to be linear, so n has to be 1. n has to equal 1. And then as for m here, if I want it to be a second order function here, the highest exponent, not exponent, but rather number in this place needs to be 2. You can't really add them together. So I would say this needs to be 2. So I'll say m is 2, but I will go back and check this just to make sure. Because you can't just add that directly. It doesn't work that way. Okay. General solution of the resulting differential equation. Okay, so a general solution. This may be a little bit more difficult, I will admit, but, might be able to do something. Finding the general solution may be a bit harder, though, generally. Oh, wait, no. Actually, now that I'm thinking about it, if this goes away, this has to be 2. Yeah. So I would get y general solution. I would get this as the actual equation for y is equal to 0. Something I could do here. I think I could convert this over, actually. Because what I could do here, from my experience, I could just turn this into this and get it to work. Although, I think this could be incorrect. But I believe this is what I can do. And then I can just subtract this over. So r squared is equal to -4 in this case. And then bring that back. I can take the square root of this, -1, and then just keep the 4 here. It's effectively what this is equal to. I could just get 2i here. Although plus minus 2i is equal to r. I don't have an a, so this will likely just be c1 cosine of 2t. 2t being this feature right here. Normally, the equation is alpha plus minus beta I, your imaginary number. So normally your general equation looks something like this. Cosine bt plus c2 eat, and then sine bt. Normally that's what it would look like, but in this case, we don't have an a value. So this is 0 in this case. So all that we have is that. So that should be the general equation of this. Obviously, I'll go back and search for it, but it shouldn't be so bad. Okay, this part is done. Now back to this question. So I have a 40 volume tank. It's half full, so V currently is not 40, it's equal to 20 actually. And then it's half full, 10 grams of a chemical. It has V's parameters. So it shouldn't take too long. This is a solution containing 2 grams per liter of the chemicals flowing in at a certain rate, and it's moving out at a certain rate as well. But it's coming in faster than in liquid is coming out. So in this case, what I'd want to see, ideally, is that change in V would be this. So it's equal to 2. Primarily because I have 4 in minus 2 out. So it's equal to 2. Now what I could do with this is that because that changes with time, my velocity equation, not my velocity equation, my volume equation is 20 plus 2t, which is quite important here. As far as my Q, which will be for my chemical solution here, I have 2 grams per liter flowing in at this rate. So I have a concentration, and then I have an intake here. So this would be 8 grams coming in per minute. And then this would be minus, in this case, I actually want this derivative here and make a bit more sense. I have a changing amount of salt. It's not consistent. 8 minus this. So I want to put my actual number on the bottom and then have this times by 2. No, 2 times 20. Yeah, 20 plus 2t. Okay. So let's take that portion here, and it's now here. And I can factor that in. But this becomes another integration factor problem, which for me, that's not too bad. I can solve that pretty easily, to be fair. So let's factor this in, and then you have a factor of 2. So you can just factor that out immediately. So you get 10 plus t on the bottom here. When the tank overflows, that's pretty easy to figure out. Just use this formula here. I think I'm at the max height or the max like range or whatever I am on this like booklet. Yes, I am. I'm drawing too big, too large. Let me make this way smaller. It's way too big. Because we're working with 5 pixels. I need to work smaller. Okay, so yeah, so I have this still, and this is Q prime. Okay, now I can just add this over and fix this equation. Actually, I'll bring it all the way up here just to make it easier to start, and we'll start with Q prime, which is our derivative in this case, and then we bring over Q 10 plus t. Well, plus, not whatever I just did there. So plus Q actual over 10 plus t. Although that will be a little bit confusing to actually be able to figure out what's what. So for the purposes of my case, I'm going to use a bendy t. Just make that easier for me to tell. And that's all equal to 8. Now, from this similar formula as last time, I know what this is equal to. P of t is equal to this function here. So this is my P of t function. And now this is the function I'll be using to do all my calculations. Now, Q. Actually, considering this is Q actually, I can drop the Q because I don't need that here. It just becomes 1 in this case to make it simplifiable because this is the actual coefficient. The Q is just part of the formula, but it doesn't necessarily matter for this in particular. No, go back a little bit. And T here, and then tiny plus here. I think it's looking at this. This shouldn't really matter to us. This is a direct conversion. So this becomes LNT. Oh, not LNT. 10 plus T. It's more accurate. Oh, plus T. Can make it look a little bit better than that. All right. Okay. And that's what it should be equal to. Now, with this in mind, E natural log, these cancel out. So you just bring this directly down. A reason being, E, the base of natural log is E, so they are similar, so they just cancel each other. They are inverses, rather. So I'm going to bring this down. So U is equal to 10 plus T here, which I could use a different variable to represent this because it would make it a little bit easier. So I'll use W. And W will make this a bit easier to remember. Okay, now Y, actually not in this case, that's incorrect. Q is equal to this. Well, not that directly, but closer to it. And then I have this function, the integral of this function, inside parentheses. Take that out. I'll add a second set of parentheses here around it, and then it's times a g of t. My g of t in this function is 8, so just scoot that down in here. Take that in. And now, for the purposes of this, I could just integrate this directly, because this is in respect to dw now. W hasn't changed. I just use that to make it easier to tell what I'm looking at. I listened a while back. I forgot. Okay, you guys are talking about Sonic stuff. Okay. That's pretty cool. Alright, so I can just take the 8 out and can multiply it back in whenever I need to. So, actually, I can just get it in there directly. For me, like, I know how to do this, so this won't be too bad. Erase that, erase that, erase that. Fix 8w. And this is in respect to dw. That's what our integral is. So, in this case, it's 80w plus 4w squared, right? Plus c. And this will all now be under 10 plus w. Now, the key thing here is, what is this question actually asking me? Find the amount of chemical in the tank at time t, or qt. Okay, this is not done yet because I need to figure out what my constant is. I have 10 initially, so when w is equal to 0, I have 10 initially. So what this should be is, this is my general solution. Now I'm going to use q. That's way too big. Q is equal to... No, not that. That's actually incorrect. This would be incorrect, actually. You don't write it in this format. It would be here is equal to 10. Now, for this purpose, 10 is equal to... So, for my entire function here, this goes 0, this is 0, this is 0, except for the 10. So, I would have 10, and then I have c. And then all you have to do is times 10 times 10. This gets rid of 10 on this block. This increases the size here. And I get 100 is equal to c. So for my case, my final equation will be q of t at any time t is equal to the following. It should be equal to, from my understanding, 80w plus 4w squared, and that will all be over 10 plus w. Well, also plus 100, obviously. So all those things will combine together, and that's the solution. Now, I know at what time the tank overflows. So I can do 40 here is equal to, subtract 20 here, go to 2t. So I have 20 is equal to 2t. So when t is equal to 10, or as English measurements would be, I have 10. In 10 minutes, the tank begins overflowing. So the relationship between the tank and everything else begins to fall apart. I'm not sure why the chat is not loading here. It should load, but I don't know. I might need to check Caster Labs and like reopen that thing. Okay, so reopening. T is equal to 10. So that's something I could test here. Let's plug it in here. So 10, I got an 800. What I can do here is times 10. I'll do quick calculations. So I have 800 here. All mental math. This would be 400. And then this plus another 100. So that's 1300 on top of 20. Top of 20. In this case, this was 10. This would be 1. This would be... If this was 10, this would be 130. In my case, this is 65. And I just know that. So, I'm going to take this off. chop the 0 at the end, and then this would normally be a 6.5, but because you chopped out of 0, this just, because you just add red here, you can just chop that down directly to 130 over 2, and you got 65. So, not bad. You can do that quite quickly. All right. Easy. Easy stuff. All right. So, there's more stuff that I have to get done. I think after this, this like test idea, what I'll probably do is pull up other stuff that I actually have to do relatively soon, so I can get it done. That will be a bit more complex than whatever you guys are seeing here, for the most part. This one I know might be a little bit confusing for some, but we will try it regardless of the situation. So I will expand that, and we're gonna get some good numbers here. So from what I'm seeing, this is a more difficult problem. I have to find y of t. This second portion is much easier. Okay, so around skin is this. So go to e 8et2 equal to e negative 3t. Okay, and that's just y1. So in my case, I have basically I'd have this function here. When you take a derivative of this just becomes boom, and then this negative 3t stays there. And then I don't know what y2 is, nor do I know what y 2 prime is. I don't know what either of these two are. Now, for this case, I believe I did a problem similar to this, but I'm gonna have to remember how to actually do it within, I guess, like a short amount of time, relatively. But I would say, because I know how this works, it goes something like this. I have y2. Actually, no. Ignore that. Ignore that completely. That's wrong. Excuse me, that is wrong. This I actually have first. So y prime, y2 prime, or its derivative, times e to negative 3t. And this will become another integration factor problem. You guys already seen this twice, so you should be able to help me get to the end here. And then this is minus this times this, but in this case, I just have plus 3e negative 3t, just due to the circumstances here. y2 itself, and then that's equal to this Wronskian here. So whatever this number is. Now, what I can do, just to make this easier for myself, is divide this out of all my different terms. So I have y2 prime, because this needs to be isolated. And then if I take the same derivative out of here, divide by this. Actually, now that I'm thinking about it, yes, divide by this, because if I divide, this becomes a positive, and then I get rid of this. So I would just get 3y2, which I'll actually close that out. I just want to make sure, probably do it on the side, just to verify that it's actually correct. Then on the side here, new t. And then if I do this, this will be pretty good, because I can do the same thing here. And what this will turn into is, I need this to write incorrectly, times e 3t. And now, if you know anything, these have similar bases. So I have e negative 3t plus 3t. And then this is time, and I have time 3 times one of this. So in this case, this cancels. This becomes 1, and yeah, I get 3 here. That makes sense. And then for this one, in this case, I'm just directly adding to the top here. So this is not too difficult. and 5c. So that's my differential equation that I get off of, the easy part. Hey, moving to another account soon. Welcome to stream. I'm not sure you're supposed to be saying that, but welcome to stream. If you meant math, that's right. If you meant the drug, I might have to remove your message, unfortunately. I don't have YouTube open. I need to make sure I don't have any references to drugs on my channel, even if it's unintentional. All right, hold on. Boom, boom, boom. It's gone. I don't see it. There we go. All right, I'll share the stream. Watch. Guys, share stream. There might be someone who doesn't know how to do math. Okay, at least from this is another initial value problem. But luckily for me, I have the advantage of this being my main number here. So I don't have to worry about too much. So because it's just 3, my P of t, so I'll make purple this time. My P of t is simply equal to 3. Now, because of that, if I integrate it, and we already know what E is going to be down here, but I can ignore that for now. E of 3, well, 3 dt, I just get 3t from this, which is pretty nice, I will admit. It's pretty nice. So, then I just have E here. Now, that's equal to U. And I can just port that directly over into another formula here, which we've already seen a lot happen so far. So 1 over this entire function here, 3t, not so bad. And then multiply it in here, which should not take too long, but it could take a little bit longer. It could take a little bit long depending on how sophisticated the problem ends up being, but that's okay. Yeah, so this is my U. And then I have E3t, and then this is my new GT here. Times 8e to the 5t. Now in this case, this just factors in, so I get 8e to the 8t. And I know a little bit of something about this one. Now this I know. I know this one for sure. How do I know this one, you may ask? So, if you don't know, et, if we take a derivative of that, it just becomes et. There's a lot of different derivation that comes into this. I won't do the derivation here because I don't know what that is. But generally, if I have a function here, like let's say it's 7, I'll just bring this down. You get rid of this t, and you just bring it down. So that's what you get. Now, if you integrate it, it's the opposite. You divide it. In our case, we're integrating our 8 function here. So this just becomes e8, e to the 8t, which I'm quite satisfied with. That's pretty accurate. It's pretty accurate, right? So we'll go on with it. And this is plus c. In my case, I have this entire thing here. 1 over, what are we talking about here? And then a to the 3t over here. So now I have a question for myself, I think. I'm trying to figure out what yt is. I don't necessarily actually know what y is, which is a problem, but I guess that's okay. I think this is how it should be. But now I'm trying to figure out what the c could be. But I'm going to be very honest. This is the final form, but I think I've made a mistake somewhere. Or at least I haven't accounted for something. And because I have not accounted for it, there's a bit of an issue. So I'll actually look at the solution briefly. Not because I don't understand this problem. I do understand it. But I need to actually understand if I'm making the right decision here. Yeah, so I got it. So I got it, and then I could just put that in there in time to see. Okay, so I just made the simple mistake of not continuing to do the work. So that's fine. I got through most. The actual math is correct. I just didn't know what the next step to do after this was. So that's okay. E5t, and then plus c e to negative 3t in this case. And from all that we know, if we look at the original equation here, that's similar to y1. So we can just ignore that function. And this is it. So y2 should roughly be equal to this. Now, the somewhat challenging part is, okay, now how do you do this part? How do you find an equation that does this? So, in our case, I have, when you simplify it, I have this case, where we have this, plus C2, E5t. So, in my case, I have two R's. I have R that is equal to negative 3, and I have R that is equal to negative 5. In this case, these have to make something equal to 0. So I know for sure that in this case, if this is trying to make something equal to 0, and this is trying to make something equal to 0, I need something here to make it work. So I'll put minus 5 here, put plus 3 here. And these will be my functions. Now I can just multiply these together. I can just multiply these together, and I should get something. I guess something pretty substantial. I'm not really sure, but we can do something here, R times R, I should get R squared here, obviously. Just mix these together. R squared, and then I have 15 on this side. Then 3R, 3 times R, and then R times negative 5. Actually, hold on. I need to think a little bit. My brain might not be working so well today. 3R, and then you have negative 5R. So you have negative 2R here. Yes? And that works. Yes, so this works. This is a factorable equation. But now I need to convert that back. So this will be boom, boom, minus this plus 15y. And in my case, this is the solution here. And that's not so bad. Hey, Jaden, welcome to the stream. What's going on? How you doing? But yeah, so this is what the answer should be. Thanks for this equation. I know the last one, solve initial value problem. I'd love to do this one. And then the last one is reduction, which, I could do. I could do reduction. I wouldn't mind doing reduction. Yeah, so let's get the entire thing in here. And let's keep going. Yeah, so let's move up. Okay, so I want to zoom in a little bit. Okay, you guys are not going to be able to see most of that. Not good. All right, so this is where we stop. Well, it's the last question. Now, if this were the actual test, I only have, what? I only have like 9 minutes. So I don't have that much time. Nothing, just chilling and exiting that my new capture card's coming in on March 9th, and the other one's coming on Thursday. And I'm trying to set up new overlay so I can be ready to stream back. Okay. Okay, that sounds good. That sounds good overall. At least from this top problem, how I'm thinking about it. This might be a little bit of a problem, but I think it's doable. It should be doable. But I think the top one, because that's pi, and pi in this case would be a coefficient. This reminds me of just getting a formula in there, which I think I know a formula that could work for this. Now, you guys, I think for some of you, I think you're in. Goodbye, Jen. You have 3 exams tomorrow. Tomorrow did my exam today. Okay. I think for you guys, most of you are in Algebra 2? No. Some of you guys might actually be in Algebra 1. You might not even be in high school yet. But you could learn something useful here. Alright, so we'll do part A first. Part B will take much longer. R squared plus this function here. And then I would get pi squared r squared. In this case, this would turn into an identity. But type of identity does matter. So this becomes the binomial expansion formula, generally, what it should be. Which would be this here. The only way to make this negative, in this case, is make r, no, that doesn't really look like a r. It looks more like a v, but it's to make r here equal to negative pi. And that's the only way to make this 0. Because this is repeated twice, it'll be okay. Bigfoot, smallhead, yo, I'm doing that now? For real? What I have on screen or algebra? What the thing that going into your screen load, did you change your subscribe thing? That's the things that's going into my screen at the top and bottom. That's the list of people who are subscribed. In school, what you're doing? Oh, okay. Okay. Okay, so this is the same root. So for this, let's get C1 here. Start working on it. I'm reading this down. Negative pi t. And then plus C2 e negative pi t. But since the root is repeated, it can be times t as well. We have, and this would be equal to y, generally. Y is equal to this function. And I have two conditions. Y1 is equal to 0, and then this. So I need to integrate, this entire sequence of events here. Not integrate. Incorrect. Differentiate. That's much better. Differentiating this. Let's ignore C1 as a concept. E negative pi over t is what matters here. So I'm get negative pi C1 e negative pi t. And that's just for the first term. For this term, I get two different things. They both still matter, but I'll eliminate the t first. So ct e negative pi t. So a repetition of what we've seen here, just without the t, and then a negative version here. And that still has a t. This could be written a bit better, I feel. So I'll write it a bit better. E to the negative pi t. And that's written a bit better. Okay, so now in this case, I have two major conditions. Y, 1 is equal to 0. And I have this second one. That's why this one is equal to 1. And just keep going. I'm about to graduate high school math. Well, I mean, what do you plan to do after high school? If you want to do anything where you're building something or any scientific field, you'd probably see this at some point. Y is equal to this. Okay, so I have these two functions. I just need to set them equal to these values here. Okay, so 1, not 1 is equal to this. Incorrect. 0 is equal to. And then when I put in 1, we get C1 e. Actually, because these are all times e to the negative pi, it wouldn't actually really matter too much, because they're all multiplied by this general feature here. This doesn't matter as much as I thought, because this doesn't 0 anything. Yeah, that doesn't make anything equal to 0. And then I have 1 here. So I need to figure out something. I need to figure out something within this area to complete it. Can you help me with my homework, please? What type of homework do you have? I may or may not be able to help you. I'm trying to think about how to do this one. Because at least considering what I have here. I can't really subtract this out because it's multiplied by this feature here. If this was 0, it would make this a lot easier. Because it's 1, a lot more time has to be spent on the nitty-gritty here. Inequalities. You gotta send me like a problem, bro. I don't remember. Well, I don't know what exact problem you're looking for, so you have to like send what it would be. Or at least try to type it out if possible. There should be equation generators online that you can use. Okay, I can't take this out of here. Maybe I should just add that back for now. Although, to be fair, actually, this doesn't matter. I can eliminate this because I can divide it over. So then I can make, in this case, because I have t would be applied to, no, actually it doesn't because it's a 1. C1 equals C2. Negative C2, to be very specific. So you can divide this over. And then this becomes C1 equal to C2, which I can just convert to that. Yeah, that makes sense overall. And then for the rest of this, it should be 1, 1, 1. And then I can just add C1 to the rest of this. So, for all of these, negative pi up there. If this is C1 is equal to negative C2, then negative times this negative pi just give me pi C2. Right? And then I have a minus pi C2 here. Because this function's now here. And this should be times 1. And then I just have C2. Okay. This is much more simple now. X is less than 6 or 9 is less than equal to X. Are you looking for a function that does that? I think I think that's what you're looking for. You're looking for a function where X exists when it's less than 6 or 9 is greater than X. But I need to know the other conditions for it. Or if that's the only thing that's there. If that's the only thing that's there, you have to think of something that makes your bottom 0 in a way. There's a lot of different functions that could do that. If you have any more information, please send it. Yeah, so this should cancel. 1, 2. So this, I could just divide this over. Although to be fair, because there's actually a 1 here, 1 is not equal to C2. It's 1 e negative pi. Or actually, to be much more specific, e negative pi here, divide underneath here. If you have a negative pi here, cross that out. This is just equal to e to the pi in this case. So then C1 in this case is equal to negative of this. So C1 is equal to negative e to the pi. And if I look at the actual definition in the work, it should be similar to this. Yeah, I got it right. So then it would just be finding the limit of this function. Here's a problem in my assignment. Is that just a problem entirely? Okay, I'd imagine just looking at this doesn't look. Are you just trying to find a function that does that? Or, because I'm reading that 2x minus 2 is less than 8. Oh, okay. That shouldn't be too difficult, to be fair. It's just absolute value. So, in this case, at least how I'm thinking about it, because you could take the 2 out of here, in a way. This just can't be 10. Actually, no. Now I'm thinking about it, I gotta think a little bit more about that one. But this shouldn't take too long. 2x minus 2. You have 2 different possibilities, because this can't be negative 8. So, you have to consider, okay, this actually isn't that bad. You just have to consider whether this is equal to negative 8 in this case. If it is, then this doesn't work. Or if it's equal to this. So, in your case, add both on this side. Negative 2 plus 8. Negative 6 2x here. And then over here. Plus 2. It's 8. 10. So, you just get x 3 x 5. Now, why is that? You just have to make sure that it's less than this number. If x is equal to negative 3, if you put that in here, you get negative 8, and then this is not less than 8. So your interval here would have to be, can't be anything greater than negative this. So it'd be something like this. Trying to think, give me a moment. You have to be greater than this. That's what your interval will turn out to be. Alright, there you go. And it didn't take too long. Yeah, but you just have to remember what two values this can't equal. If it's equal to negative 8, then this is negative 8, this turns to 8, this doesn't work. If it's 8, then this doesn't work. You just have to make 2 equations. It doesn't take too long to do. I'll keep that available, just in case you need to reference it again. But I'll try to complete the problem I just had. Alright. C2, and then to the negative pi here. Okay. Now, what's my original equation? Is it this equation? Okay, now considering that, if this is the case, then ideally, I still have that e to the negative 2. So, I think this is ideally what my equation would be. E here, to the pi, and then plus e pi times t. That should be my general equation. And y is equal to that. That should be what that's equal to. Or something similar. In this case, it's t minus 1. Oh, you can simplify that even further. That actually does make sense. Actually, that makes a lot more sense now I'm thinking about it. This the next one. DT. Oh my goodness. I'm not sure if what you typed is actually formatted correctly. So that first part should go away. Because I'm not sure if you have a 2t or if that's a t squared. Like, I'm not able to really tell. In that case, you can just use the summation product. Actually, no, you have to use integration by parts there. Just use integration by parts in that instance. If it's 2t, ln that, you can just use integration by parts. Derivative out the first part, and then integrate the second part there. And you should be fine. There should be a tutorial on YouTube to do that, but ln in this case you can't. Actually, no. Actually, now I'm thinking about it, you can't really integrate the ln function here. You'd have to, because you have to keep differentiating that. Actually, hold on. That's to give me a little bit of an idea. You can't really integrate that. It's a good one. You went on ChatGPT to ask for a hard calculus problem? Oh. Mate, I thought you said you were going to give you your actual homework. Dude, the first one on the homework was actually so easy. This part, I had to think a little bit more about. But don't have to do it like right now. I'm just kind of looking at that. It's like, what is this? Trying to integrate that. There's something that I'm gonna have to go back and look at because I don't remember how to fully do this integration technique here for 2t. Not 2t, but the ln there. I don't remember the integral for that. I know there is one that's hyper specific, but it would be take a little bit of time to get that done. What was I about to do? Yeah, I was supposed to write out this. Brain is having a little bit of an issue now because I just have to think about other stuff. Okay, I can just take this out and then times it by this function here because they're all multiplied this way. And then I have positive 1 in one case. Oh, t minus 1. But I don't think that's how they wrote it. No, they did write it that way. It's asking for the limit of this as it goes to infinity, though. Right? I believe it is. Yeah, that's what it's asking for. Okay. If this goes to infinity, then hypothetically this would also go to infinity. Well, it should go to infinity. But considering this is a negative number, if this goes to infinity here, you get infinity here, and then you just get a negative, so you get negative infinity. That's where it should go. But in reality, the limit here is 0. So I've done something incorrectly. Oh, I've made a mistake. This is supposed to be negative. In that case, never mind, that is incorrect. In that case, duh. In that case, if this is negative because I made a mistake here, then this is just... Okay, so I have infinity underneath here, and that goes much faster than this. So I get 0 times this times that. So then, yeah, the limit would go to 0. Yeah, that's what it should be. All right, what I'm gonna do, at least for the moment, is to save this. So actually, I don't know. Can I block that out? Yeah, I'll block the Microsoft Paint function here, and I'm going to save this to my computer. And I'm going to pull up something else that I know I also have to get done. So math common. Okay, so for this case, that's fine. And I'm going to make a new file now. And the new file will have very similar specifications as the last file. Okay. And bring screen back here. There we go. And let's start doing something. Big question for myself is going to be, I need to get triangles on this screen. I'm not quite sure how, but I need to do that. Okay, so I know I need to do couple moments as well, but I'm trying to figure out how to both get, that's actually wrong. I need to both find out a way to get homework done. Actually, this might be actually easier to get this one out the way, because then I can write it down on a piece of paper. And once I write it down on a piece of paper, life will be pretty easy afterward. I went to Burger King to get the burgers. Okay. How many did you get? Alright. Now, one thing I'm actually struggling with personally is actually trying to figure this problem out. And I have to convert that to both polar and Cartesian. Now, it's already in Cartesian. This is the Cartesian representation. But I have the issue of, okay, I need to convert that. Around 6 or 7, maybe. Okay. That's not bad. That's a pretty decent amount of burgers, I would say. So, I think that's okay. Okay. I'm trying to think for a bit. Because I know how to convert this generally over. But I'm guessing I might need to find magnitude a bit earlier. Because this is... Actually, no. This would be incorrect if I were to just directly use this to do what I needed. Because I have this 10 power here. The key problem is I'm trying to remember, and I'm trying to figure out, is there a way to get this done efficiently where I can skip the process of getting the exponent to all these sides. Now, I could Google stuff. So, for example, complex numbers to exponent with exponents attached, and try to slowly figure out how you do something. But I think this could be complex exponentiation. I'm not fully sure. Now, there's another way to do this in theory. But that would include, okay, from my perspective, that would include manually multiplying out everything. Which I'm not really sure if that's ideal to do. Could be done, but should it be done? No idea. But, there's a long way and there's a short way. Because I can easily convert that over. So, I actually just found an article. It's actually helping me. You're gonna crash out? Why? I just found an article. It's actually helping me out quite a bit. I actually want to make this into polar first. Seems to be. And then once I do that, I'll be in a good shape. I'm not sure if that will work, though. T of 10 equal to this of 10. This of theta. But, oh, no, never mind. Never mind. Pi I. 10 over 4. 8 pi over 4. Oh, yeah. Actually, no, that does make sense. That does make sense, actually. Yeah, because you could just directly get numbers and then add said. Yeah, because you could just convert this to polar directly. Oh my goodness. None of your friends are online? Oh. Oh, goodness. Okay, so actually, working backwards, I was thinking about this as a potential idea. Bringing this down, because I was thinking like maybe you could do this. Maybe I'm not sure exactly if you could do this, but if you can, it's huge. So we could square this right now and get a radius. And once I get a radius, I can get r e to an I theta. And then I can also get this exponentiation to the theta that I'm looking for. So, if we can get that exponentiation in there, we'll be in a very good position. In this case, I get 3 squared here. Yeah, so from my perspective, this is 3. Then I get 9. And you get 12. Well, square root 12. And then you can break that up into 2 square root 3. Now, if you don't understand, we could break this up into square root of 4 and then square root of 3. That's what is multiplied to get to. You could do that. So you get this function here, which is pretty good. Okay, so this is equal to r. This is my radius. As far as my angle is concerned, I don't have this feature per se, but I can use the tangent of this, right, to get what I'm looking for. Square root 3. Now, I need my calculator because I can't do mental math in my head about this. Only source of comfort isn't responding. I barely get to talk to my boyfriend. This is me being calm. Oh my goodness. Oh. Oh wow. Hold on. Where's my calculator? Oh my goodness. Where is it? Oh. God. I think my legs have lost a lot of energy. Like I can't move that well. But that's okay. Is there anything that you can do while your boyfriend's not talking to you? I'm not really sure if there's anything that could help your situation right now. If there's anything that you want others to do for you. Okay. Tangent of this divided by square root 3. This is negative 1.4 radians. But I need to turn that into pi radians just to make this easier for myself. Okay. Now divide this by pi. And I should get negative 0.333 radians. Pi radians. And that's my angle. It's equal to theta. And this is repeating. So, what I'll do That's my radius. Then I'll take this and convert directly to polar. So I'm going to have my polar section here. And I will write this on a sheet of paper so I can take a picture of it and submit it tonight. I want him to... No, I want him to... He always makes me feel happy. Okay. Who? Oh my goodness. Their boyfriend makes them feel happy. Oh my goodness. Oh wow. This is to the 10th. Yes, it is. Okay, so in my case, if this is all to the 10th, then I get 2 to the 10th here times 3 to the 5th. And then I have well, not I, but J. And in this case, I have this angle here. Well, I need to raise that to the 10th. First off. Because that's what they did. And I need to make sure I do that. Well, no, they just said they had one, though. The gender fluid, so I may also refer to him as my girlfriend. Yeah. I mean, as long as they're able to respond to you soon enough, that would be good, I think, overall. Hold on. Negative, okay, so if I times that by 10, I would get, I think I get negative 3.3 here. So, negative 3.3 pi. Now, as far as I remember, this can break up into 2 pi I, and then another one. Okay, so that's actually equal to 1. I did not know that. So if that's equal to 1, then I just get I. So in this case, I probably get a negative 1 here? No. No, that can't be the case. I can't get a negative 1 from this. But maybe I can break it up. So EJ to the 2 pi. Oh, negative 2 pi here. And then an E to the negative 1.3 pi on this side. So I'm thinking maybe because this is already the simplified Cartesian form, then this has to be my simplified polar form. Most likely. I'm not saying who because I don't know if she wants me to yap about it. She can't. She's in Australia. I have nothing. I mean, if you know they're not, if you don't know, then yeah, it would make sense not to talk about who it is, at least for their privacy. That would make sense. Ooh. I'll keep this the way it is. This will turn into, no. E to the negative pi. If this is 1, then if you put a negative there, I'm not sure if that becomes negative 1. I don't think so. To me, that doesn't make, at least for me, I'm trying to understand, it doesn't make logical sense for that to become negative 1. Maybe it does. But negative 2 pi and 2 pi, actually, I can just factor out 2 pi and keep the negative there. If that's the case, then these two, no. Because if they're multiplied, you add them. So, this is a good question. I don't think that becomes negative. But in case it does, I'll make sure that it's represented this way. Fifth, times this. And I'm not fully sure if this is accurate, but I'll leave this as my polar. And then, as always, the Cartesian is over there, so this is just my Cartesian form. Yeah, so this is my Cartesian form. I don't want them to get overwhelmed because he has social anxiety. I understand. Yeah, that makes sense. I mean, if they're not checking in on you, it would make sense to, like, just keep trying to check in to see what's going on. Oh my goodness. I think this is correct. This answer here. I believe it's correct, but I'm not completely sure. I have to do a lot more digging into this one because I want to make sure I actually got everything correct from this particular answer. But I think overall, I have something that's at least logical that's highlighted. I believe it should be logical, at least in some way. If it's not, I'll ask the professor about it to really understand what's going on here, and then I should be in a good position. There is another question on here that is asking for, I guess, maybe a sign? I'm trying to figure out what exactly they want. They don't have a question format. They have an equation. And they have a period, they have a phase shift, they have all that good stuff. But I don't actually have, for example, a question. Now, I'm not sure if they want me to plot that. If that's the case, then maybe I could get to plotting it. I have no idea. But maybe. I'll probably ask the professor about it. But so far, almost everything I have is done. From at least that math exam that I did, except for the reduction question. And then this. Something I do want to do, though, is at least probably help myself prepare for two things tomorrow. Ideally a quiz, and the second thing being, I'd like to prepare myself for at least getting homework out the way because there's a decent amount of that walking around. So I want to get some work started on those different things. Okay, so I'll pull up another assignment and see what's going on here. If it doesn't copy, I'd say order from It's a Very Good Song. Me knows. I think if someone's like not talking to you, you have to like, at least for me, a lot of times you have to wait to really see what it is. You don't really have too much choice over it. Like you could check in, right? Try to check in. Like I've done that before. But it's a hard situation to be in because you don't really know what the person who you're talking to is going through at that moment. So when they're not talking to you, it does hurt. And you don't know why. I don't really know what to do for that sort of circumstance, even though I've been through it, because I haven't found something that works. Each person is different from my analysis. Each person's very different. I think I found something that might be good. Now, I can't reproduce problems? Actually, hold on. I need to see something. I need to Google if I'm allowed to 350 if I'm allowed to do problems. Because I'm not sure if Pearson actually allows you to show specific problems. Okay, it seems like I can. Alright. So what I'm going to do is I'm going to take a picture of some of these problems. Because I might actually struggle a bit to figure out what's happening here. And I have a pretty good one. That I could use some help with. If you guys think that math is hard now, you guys have not seen anything yet. That's like we got a pretty good one here now. Okay, so I need to find the forces in all of these cables right here. And this is a bit of a problem because I need to figure out some position vectors. Okay? But I think I can do that. Generally speaking, I should be able to do that. Okay, so this is 2.5 feet away. Actually, now I'm thinking about it. Hold on. This is 2.5 feet away from the z-axis here. This is 3 feet above 4.5 feet. Yes. But all of these different strings attached have to differ in some way. And that will be a bit of a challenge. But I know it will be challenging. But the key here is actually be able to understand what's happening, be able to do the math, and if I can't do it, search up online a way to get it done. That should be the ideal goal here. Because this is not a typical free body diagram. Okay, so I'm going to draw a free body diagram. It's already drawn for me, but I need to figure out my forces and the corresponding angles. Now, CD, I need to find forces in all of my cardinal directions. This BD axis, this is in terms of Y. So force in Y direction, I know is just BD, which is 1.5 feet. And I need to find... I need to find the angle, yes. But it doesn't matter as much for what I'm looking for. So BD is, in this case, is equal to this. This is in the Y direction. Just BD. And then I have CD does not go in the Y. Oh, no. Does go in the Y direction. It does go in the Y direction. This is negative BD. This is, in relation to my box here, this is also, this is 1 foot removed, so this is in the positive direction. But I need to find the actual angle here. Yeah, so I need to find this. Distance here. But I know there's 3 feet in the Z direction. So I should also get that down. Because our force is moving down in the Z direction. So I need to understand what exactly is happening here. Rocket League players are so toxic. Loser is saying what a save when Bro Lily was the one that missed. I mean, people are like that sometimes. Okay, wait. I have 20 pounds, right? Yes. I have a force of 20 pulling down in the negative Z direction here. Okay, so I need to have negative 20 somewhere on this end. Negative 20 somewhere on that end. I'm pulling a bucket down. I'm trying to pull a bucket down. What are the forces I need to consider here? I don't have Z for the BD direction. I have one in the CD and AD direction, though. Okay, so I go up 3 feet from this plane here. So from this plane here, I'm going up 3 feet from where this bucket is. Or point D is. So I'm going up 3 feet. So I have an AD one here. And this would be relative to a sine direction. This is up 3 feet, and I need to get the triangle for this. So, I know AD is here. I have 3 feet here. I have 1.5 feet here. I need to figure out what this side is. This is my triangle. So what I can do, hold on. I don't even know what the sides are. That's correct. This is a right triangle, but I need to figure out what this side is. So, I can just do this to help me out. Just do this function to help me out here. So I need to figure out what the length of this side is. Similar thing here. 1.5 here, up 3 feet. Same thing on this end. So both of these triangles, actually, now that I am looking at them, they seem to be very similar. I'm not going to get wrapped up in this. I'm going to go by. Hope things get better. Please don't go. Ollie, I'm guessing. Oh, wait. You guys are talking amongst yourselves about what's happening. Hold on. I think these triangles are identical. At least from how this is positioned, the triangles here seem to be identical. I'm not sure, however, and I will say this, I'm not sure how relevant these actually are, like this 4.5 foot and this 2.5 foot here. I'm not sure how relevant these two measurements are here. I'm not too sure. But I do know that the C and the A, they're up 3 feet. And they have similar triangles. So they have similar... They have the same... what do you call it? The length is the same. I'm at the baseball. It's getting late and I have some circuits to work on. It's been a while since I last worked on circuitry. I'm a bit rusty, but if we ball it... Okay, Jero. Okay. Do well with it, please. I'll continue streaming. I have some time. What do I do here? This is really actually making me think, because I have to think about a lot of different variables here. It's not very simplistic, where it's just 1, 2, 3. This is actually I have to think a lot. Okay, so I need to get this sum here because I need to figure out what this length is. So I see a similar length is available on this right side. I gotta see what it is though. So this is saying 3.35. Okay. In my case, this sine is 3 over this. So that'll be my sine angle, which is not bad, I would say. But I would consider if this is what it is for both AD and how do you even draw an and symbol? Oh my goodness. And this is what it is for AD and CD from this position. Then I would also think generally that maybe these are the same. They have the same angle. So let me divide this right now so I can get a number here that is easily accessible. So I do have to do this on paper, but if I have it on my computer screen, it will be much easier just to go back and forth here. Okay. This is 0.8 9, 5, 5. So I'll round this up to 5. Just put the 5, 5. Just make it easy for myself. Yeah. So both AD and CD have that force. So that's a positive for me. AD is equal to... Wait, no. I just thought about something. I still can't do that. Why? Because even if these are equal in this situation, they're not necessarily going to be equal in... Actually, no. They're not necessarily going to be equal in these other positions. Because if I'm pulling to the back there, which I am in this case, I'm pulling in the negative x direction. Whereas these guys are pulling in the y direction. And I think maybe I'm getting it now. This is how far? Because this is not, if I draw this up, this is not on the direct plane going here. So I think I've actually figured that out. There is some force here. Some force, whatever it has to be, that's pushing this to the side here. So that's why these two measurements are useful. Okay. This is still going to be difficult. I can tell. But, I can do it, though. I can do it. Even if I don't feel like I can do it right now. One thing I'll do, I'll add the timer text so people know how long it's been. So, if I could find a timer. Yeah, so stream time, I'll put it on this part of the stream. It should be available. People, I'm not sure why it hasn't been, but I'll get the stream time there. Okay, so I need to figure out where this is. This is 1.5. Oh, I'm an idiot. Okay, I got it now. This is 1.5. This is shifted over 1 foot. This is 1.5 away from this. So this is a shift of 1 foot. That's why that's useful. Okay, I got it now. Because this is going to help me explain. Okay, this is pulling 1 foot in displacement in the x direction, slightly. And this is pulling in the y direction, some slight degree. Because this is also 1.5 feet. Whereas this here is 3 feet. I actually think maybe I need to find the actual... What's it called? I need to find the actual force, the actual position vectors. Welcome back, Jaden. Welcome back to stream. Yeah, I need to find the position vectors. That's one major problem I haven't actually done yet. I haven't found the position vectors. I haven't done a position vector yet. The position vector is what's going to help me figure this out. Because then, if I know the position of RAD... Yeah, I'm making a mistake. What am I doing? Oh my god. Okay. I need to get my brain checked. What am I doing? Go back. I need to find the positions of all of these relative to this bucket. That's what I have been failing to do so far, and that's why it's taking a lot longer. I need to get the positions of these and their magnitudes so I get the unit vectors. And then I can use that unit vector in these equations that I'm going to build here. So I've made a mistake already. But that's fine. I can work with that. Okay, so I need to eliminate a lot of this right now because I don't know. I clearly don't know what I'm doing. The brain is having a few issues today. But it's okay. I've been doing a lot of math so far. So, if I don't get it immediately, I will get it at some point. Forgot how easy to make circuits, well, basic ones at least. And then I'm looking at this. I just realized I messed up with not even remembering how to do position vectors again. I just completely glossed over the fact. So I gotta make position vectors for all these things I just missed, but it's okay. Dang it. Ah, man. I feel dumb now. I don't like that. RAD. I have to zoom in for this. Scroll over. Okay. R A D. Okay. Compare to D. I am starting at D and I'm moving here. Okay. This. Actually, I need to find the positions of all these things. Why am I so slow? Oh my goodness. I can't believe it, but I'm actually slow right now. Okay. Now position of D, of A, of B, and of C. I'm gonna get all these down. Because I need these to make my life much easier. Okay, got it. Now, RD is 1.5 feet in the Y direction. So, to get the vector notation up there. 1.5 feet in the R direction, in the Y direction. 1.5 feet in the X direction. And in the Z direction, we are at 0. In the RA direction, I am 4.5 feet in the X direction. Positive X direction. I am 0 feet in the Y direction. Okay. And I am... What else? Whew. Oh my goodness. And I am... whatchamacallit? 4.5 feet in the X direction. 0 feet in the Y direction. And I am 3 feet in the Z direction. There we go. As for RB, I am 4.5 feet in the X direction. I'm still 0 feet in the Y direction. And I'm 0 feet in the Z direction. And as for RC here, just getting all my bearings straight. This is how I'm going to get the positions for everything. Just to make stuff easier. This is gonna help me. RC. Where is C? C is here. I have 3 feet up. Yes. 3 feet up in the Z direction. So 3 feet here. I am 2.5 feet in the Y direction. It's a little bit harder to write, but I'll zoom in here to give myself a little bit of space. Okay, take that down. I'm 2.5 feet in the Y direction, and in the X direction, I am 0 feet. Okay. Now I'm looking for RAD. RAD. I'm more looking for RDA. So I'm looking for terminal minus initial. So in this case, I have 3 here minus these 2 vectors. This is my term. This is my end. I have negative 1.5. And I have, oh my goodness, negative 1.5, and I have, in this case, I have a 3. So I have 2 3s. This is my vector in that direction. I'm looking for R, and I'm looking now for CD. So DC. Okay. Now, I have 1 vector down already. I need to get 2 vectors down. I don't have enough vector, so I need to get more vectors. Block this out. And let's keep going. Okay, so RDA, DC, C, I already have everything here. So C here, 0, this is 1.5, so we're moving backwards. No, actually, yes. So we're going back 1.5 in the X direction. In the Z direction, I need to pay attention here. In the Z direction, we're going up 3. And in this little small area here, that is a 1 foot increase. And then the last one is DB. And this should be the easier vector to get done. Okay, so I have 0 in this direction. Okay. No, wrong. Just incorrect. 0 in the Z direction. So 0 here. In the other direction, it's RB direction, I have, in my case, 4.5, I have 1.5 there, I have a 3. And in this case, for Y, which is this one, I go back negative 1.5 for whatever reason. Okay. Now, for all of these, I need to get their magnitudes now. So I need to get a magnitude of all of these. And then I need to get their unit vectors. The simplest way to do that is I have to actually add my points here. So I will do that. I hear people outside like moving their cars and stuff. It's quite unsettling, I would say. But I will continue. I should be pretty safe, I think. I don't know. I need to change my hashtags, but for this stream, it's okay. -3, -1.5, 3. I have all of these, so I need to now just get everything done. Okay. So RDA, RBC, and RDB, DC, and then DB. And then, obviously, that will be the position. So what I need for this one, and it's because I'm doing this for myself later. My handwriting is also pretty similar to this. Okay. But I will try my best here. And I need to decrease my pixel size a little bit. Okay, so I have 3 squared plus 1.5 squared. I don't like that. That's not right. Plus 3 squared. And then same thing for all of these other ones. Plus 3 squared. And then This is just 3 squared. Oh, not like that. 3 squared plus 1.5 squared. Now, once I take all of these and I decompose them, I should be good. And what I mean by decompose them, I don't really know. I need to just turn into numbers. Is Taru okay? I don't think so. I don't believe they're okay for right now. I don't think they're okay. Um, 1.5 squared. This is 4.5. Okay. I have like 2 other ones here. Oh. Okay, 3.5. They're mainly waiting on their boyfriend or their girlfriend. Their boyfriend slash girlfriend. They missed them. So it's gonna take until that person messages them for them to feel okay, I think. Which is quite sad because a lot of people they might not be able to talk to who they like again. I've had that happen to me before. And it was not a very pleasant experience. This is 3.25. Okay. Now I have this. And because I know what I have at the moment, I should be able to interpret this. I hope they haven't done anything that they're going to repent. What do you mean? I kind of doubt that would happen. I have all these numbers here. This becomes... Actually, I should just do the calculations of everything. Because then I'll be able to actually tell in detail what forces go where. So I'll have the numbers here. So I'll be able to have e to the x now. I'll be able to derive it and put them inside of these functions here. BD is not there. Okay. I don't want to make any more problems. Good luck, Storm, and good night. Alright, good night, Jero. Thanks for coming to stream today. I know there's not too many people on stream. I don't think people usually like streams like this, but at least you came by. So that's a good thing. Alright, so I'm just looking at this. It would be easier to get all the forces down. So what I'll do is divide each of these by their respective forces and get them where they need to be. Because I don't really see too many negative values here. Okay, and that's 0.666, and that's for dA, right? Yeah. So this is just 2/3, and that's for the positive dA direction. So I'll just put AD to simplify it. And I have these other forces. Okay, so negative 0.4285. I think I could round that, but I prefer not to. I think 86 is better, just so I don't over round. And that will be for CD. And then, in my case, I have this other one here. So this is for this 3 icon here. 3 divided by 3.25. And you can add that there. Oh, hi Daisy, welcome to stream. Okay, so divide this. Yeah, I'm trying to think, actually. If I have 3 divided by this, I have the number. So I'll put this here. 0.8965. Okay, and this will be for DB, or BD in this case. BD does not have a Z component. And I have to do the same thing for all these other ones. I'm not sure if I want to just stop with those. So I want to continue to go further. Because I know I can use these as a way to simplify the forces. And then it shouldn't be as difficult. Also, welcome back, Ruby. It shouldn't be too difficult to do. Not by 4.5. So this is negative 1/3. In this case. And it's just for my Y direction. And this is AD again. And what I have next, I have 1 divided by 3.5. And this is for DC. Oh, CD in my case. 0.2857. Now I could obviously write this much faster, but it still takes a little bit to get everything done. Yeah, both you and Tara are missing someone right now. They're missing their boyfriend/girlfriend. You're missing your boyfriend. I don't know where they are, but hopefully you guys can talk to them soon. What do we have here? This is CD. This function, I think I'm not going to be able to read this that well later on. So I would like to change this. It's more so just a handwriting problem. Because this is 2857. Okay. 2857. And there we go. And then what the next one is, just zoom out a little. Because I need to get this last force. And this is for dB. So this is also a negative force in this case. But it's divided by 3.25. And this one's a bit higher. So negative 0.44. 776 is pretty accurate. I'll put 778 here to make it easier. Okay. BD. And then for Z, I would just have 2 forces. So 3 divided by 4.5 for A. And get the same thing here. AD. And I have this for CD. So let me get that force in here. And they're both going actually, yeah, they're both going in the same direction. But this area is easier to figure out because I have an actual value available to me. 8571 CD. And then my weight going down. Just in kilograms? I think I might have deleted the part of the problem that answers the question. But it says 20 here. I think I might have deleted something by accident. Let me check. Actually. What was the problem saying? 800, no, wrong one. 20-pound cylinder. Okay. That's a force. That can be worked with, and this is minus 20. Okay. In terms of making this, this will be my system of equations here. In terms of actually making this easier to deal with, I ideally want to factor out some of these values up here. That's what I would ideally try to do. The question is, at least for me, how should I factor out said values? That is the harder part of this sequence here. Simply because it's just a lot of moving parts available. But considering that like in one direction there's only one force, so I'm actually a little bit surprised by. I think BD may actually be incorrect. I think I might have put that force to be incorrect. So BD is, well, it's 4.5 feet in the X direction, which is the same thing for the bucket. Oh, wait, hold on. Oh my goodness, wait. I think I actually made a mistake here. That's not 1.5. This is, no, it is 1.5. That is questionable. I'm wondering, oh, wait, these are not on the same plane. Hold on. Duh. These are not on the same plane. This is different. This is 1.5 feet here and 1.5 feet here, and it's just connected directly. Okay, wait, so I've made a complete mistake here. This is 1.5. There's no force in the X direction either. There's only force in the Y direction. My apologies. I've overcomplicated my problem. That is not good. But, you know, for BD, in this case, if this is 1.5, then that's 0. So I only have, eliminate this. It's a concept. This is 0. So I don't have an X force. Oh, man. Yeah, so you can see as I'm doing these problems, there are a lot of different ways to mess this up. But as you're seeing me mess it up, even though it's taking a while, you're learning a little bit more of how to do problems, I would say. And I think that's what matters, right? Okay. So, yes, because then I can plug this feature into this equation, and this equation into this equation. And once I'm able to do that, I should be able to get everything. But I need to make sure I'm actually able to get this correct. So this is wrong. This would just be 1.5. And I'm 100% confident in that. This is just 1.5. Because all the force of BD is in the Y direction. And all the forces. And that generally makes sense. Not what I just had. So, minus BD. There we go. Okay. So, what I want to do is I can add these to the other side, which this should be 0. 0.6680 is equal to this function, and then it would be plus 20 this time. So negative 0.8571 CD plus 20. That's what this function is equal to, and then I just divide this over. So then this would become times by 3 over 2. So let me see what my answer would be. Because I am quite interested. Times, actually, no, divided by this function. Although this would be incorrect, it would be divided by 2/3. So I would get a 1.28 for this function here. 0.285, put 286, just to make it a little bit easier to calculate. AD as a function is equal to this CD, and then whatever the plus 20 region happens to be. I think everyone is left, but I'll continue to go anyway. I think that's okay. Yeah, I'll continue to go. And then 20 divided by 2/3 is 30. Okay, so I get plus 30 here. Now I can plug that into this top feature here, and I would just get this function spit back out. So I will get, and this is in the y direction, EY, and then it should be equal to 0. So 0 is equal to this feature right here, 71 CD plus 20. And this is subtracted by this other feature, which is 0.4286. And this is the CD function. Okay, so using the CD function, I can put those together. I get negative 20 on one side is equal to, and then when I sum these together, I would get. This is actually the first one I begin to solve, which is good because then I can go back to the original equation and plug that in directly, get AD, and then plug it into this final equation to get BD. And then I solved this problem, even though it's taken me a long time. It's been about like 30 minutes or so. It's taken a while, but I think I'll be better off for it. At least that's how I feel. I might be better off for it, like long term. Somehow this stream has 115 views. I'm not sure exactly how that's possible, but you know, it could work. I would love to do dual streaming to shorts. That would be cool. Okay. And I would need an encoder. But yeah, so what I would do, I would love to stream to both the shorts platform as well. For YouTube. That would be good to at least have this stream. I mean, I'll probably have a vertical overlay and just get that also onto YouTube Shorts because someone may be interested in like watching how to do math. I think that would be pretty cool. It's all like very useful here. Okay. And then 0.8571 minus 0.5286. Okay. And I believe that's all correct. So I get this number here. It's actually quite surprising, I would say. The numbers do line up. CD. And then if I would do the conversion, negative 20 divided by this, then I get my CD is equal to 15.555. Well, triple 5. And then double 5 and then a 6 because there's a 7 here. So I'll just round up. Okay, so I have this function here. What I want to do now is plug this back in to this equation. So we're going to do exactly just that. Now this is for AD. But I do think, generally, if this is the function, then, you know, might be time to get a little bit of an upgrade here. Times this number. No, so I want my answer times this number here. Ooh, and now I'm pretty smart. So now what I get here is this times that 15.555. This is equal to negative 20. And plus 30, that's equal to 10. And this was equal to AD. So I know AD, the force of AD is equal to 10 pounds. right? I got that now. The next thing I need to do, because I have these two numbers, is now I have the y equation. So I can just plug everything back into here. And that should be pretty easy. This shouldn't take an excessive amount of time. But, we'll see. We'll see what it takes. So, 333 times 10. And we'll sum it together. 0 is equal to this. Should be. And then get plus 0.285. I didn't mean to draw it like that, but 15.555. So 15.556. I'll round up just slightly. It won't affect the end calculation too much because it's very minor. But I think we'll have an idea here soon of what we're looking for. Okay, so this is BD. Now, what I want to do is I want to make a summation of all of these. Okay, so I need 0.33 times 10 plus 0.2857 times 15.556. Now, from this, what I get, and this doesn't really, wait. Now, actually, I'm thinking about it. Wait, I'm thinking about this. Wait, the BD force feels a bit too low. I just kind of realized that feels a little too low. I have here, because this barely outweighs this. Unless that's incorrect. Which it should not be. But you never know. Alright? Yeah. So I would say I have 1.11 in this general theater of operation. 1.14 to be exact. And that's equal to 0. And that's minus BD. Now, I know that BD, just add that over, is equal to 1.114. However, I'm thinking about this. That feels too low for me, so I might just avoid it as a concept because it feels too low. It could be lower, though. But unlike what I see. So I'll keep going. Okay, so, just considering that, I think, right, that this is pretty good, I would say. So, I'll list out my forces. And I have AD, BD. BD is like is a smaller balancing force, and then CD. Okay, I know what all these are equal to. 10, 1.114, and this is equal to 15.556. These are all in the units of pounds, roughly. So, congratulations to myself. That's one problem done. That's taken a little while to think about, but I will admit that's not bad. I think there's definitely a chance that it could get, I guess, better or worse. Yeah, I'm still doing homework right now. This problem in particular, I have to go back and fix it because I made a mistake of not including the force projections. Like, what am I talking about? I made the mistake of not including the position vectors properly. So I had to go back and fix it. And I got these answers down here. Now, I have to go back and check these before I actually put them onto a homework sheet that I'm going to print out later, for example. But I think generally, this is pretty good. This is pretty decent. And I like the representation that I got there. So I like it. I think it works, but I definitely have to go back and check it just to make sure everything makes sense. Okay, so I have another question that I gotta get done. No portion of this may be reproduced in any form, any means, without permission. Okay. Okay. I didn't mean for that to happen. Okay. I have this problem now, and I'm working overtime to get this under control. Yeah, there's a lot of work for one problem, but to really get it understood, it's gonna take a while. But it's worth it, I think. Okay, so this is another problem I have. Okay, so I got this. And then I have a cylinder. Well, I have a cylinder. A 100-pound cylinder to be exact. So this is 800 coming down here. But I have a distance of 1, right? And I have a few problems actually. I have a lot of different what you call it. Oh, thank you, African Dancers, for the follow on Kick. Thank you. For this issue of the problem that I have, 360, I have a lot of different angles here, and it's looking a bit, difficult, but, try and see what's possible here. Now, all of these do sum up to get me a force of 800 pounds. What I'm looking for is to figure out, okay, what are the units of distance? If I zoom in here, I think I can see me zooming in. Yes. So let me just get 800 to look a bit better. What I need to do, from my perspective, is I need to connect these two factors here. So I have a 135-degree angle here, a 90-degree angle here, 135-degree angle here. Oh, wait, hold on. Actually, I'm thinking a little bit. Wait. This can't be... This is not a full 90. I just realized that. Because if I were to do some math, well, use a calculator, it's not nearly as simple as what that presented to me. And it's my job, at least in this case, to recognize that. Okay. Ashton isn't answering me, and I gotta go soon. Like I said, the only thing that you can do is wait, unfortunately. That's all you're gonna be able to do. It's a tough situation to be in. Okay, wait. I'm trying to figure this out. This is my x-axis here. This is my y-axis. This is 1 foot. So this is 1 foot the entire way across. And look, just giving it a look, seems like I have 1 foot going this way. And then I have a triangle here. So I have a triangle here, with a 90-degree angle here. It's 1 foot up. And I'm trying to figure out, I gotta figure out the distance to the central point. But now I'm thinking, actually, this entire thing is a radius of 1, no matter how I look at it. The real question is going to be, okay, what is the length here? So this is a length of 1 in the y direction. But I'm trying to find it in relation to this A point. This is a length of 1. But I think I might have made a few mistakes. Yeah, D's 1 foot. Oh, it's really a bit difficult. I was gonna ask if he has work tomorrow. I mean, they may or may not. I don't know. I mean, how would you know, though, to be fair? How would you even know? Unless they explicitly told you. Yeah, so I have 1 foot here, seems. And this is just to get to point B. I have 1 foot here for sure. But I have a lot of different angles. And I know this entire increase here is 1 foot. Okay. But I'm not sure if this right here is what I'm looking for. Because I know this is 1 foot. But I think it's going to be difficult to at least be able to get around. What kind of fresh engineering are you doing? What kind of engineering are you doing? I have no idea. Man, I'm trying to figure out how to hold up this chandelier here. It's a bit difficult. Well, that just means they haven't checked Instagram yet. Well, they could see your message, but that just means they didn't open up their chat. To be more specific, this is statics. This is homework, but it's statics. It's the actual subject that I'm looking at here. So I know this is 1 foot going up, and I know there's 800 pounds at the bottom. And I know each one of these cables combined together in this Z direction is going to help hold this thing up. But the real question is, I actually have to find this. I have to find the angle here, which is the hard part, actually finding the positions of everything. Dubs, I took that class. Did you like it? Did you hate it? How did you feel about it? Okay. Compared to A, these are all above 1 in the Z direction, so 1, 1, 1, 1, 1. Let's get these all in. I probably won't finish this on stream. I just want to get it set up for later. Okay. This other stuff is going to be hard in retrospect. Okay. This is 1 foot in this direction, but I see a few problems. I'm going to be honest. I see a few issues, at least looking at this angle, trying to angle this out. 135 here is from this portion all the way here. And 135 is from this portion all the way here. And it's somehow a 90-degree angle between these two. I don't fully believe that. But I'd imagine maybe there is. But 135 here goes to this section. So does it go here? But I imagine maybe what's happening is that this entire area here could be considered a 90-degree angle. Maybe that's what's happening here. I'm not quite sure. I gotta go now though. Bye, Storm. Good night. Good night, Daisy. It was neat. Definitely made me frustrated. Yeah, I could definitely see how it can make someone frustrated in general. That would make sense, considering the type of calculations that we're doing here. I'm just thinking from at least how the angle is orientated. I know that 135 plus 135. Oh, wait, hold on. No, wait, this does actually sum up perfectly, though. If this is 135 here, and this is 135 here. Wait, I think I might have figured something out, at least with the angles. If this is 135 from this section to here, and this is also 135, and this is 90, then the goal will be finding a portion that makes this 90. Because I can somewhat identify it here. where this is 135 triangle here, and this is also 135. But I imagine to make it easier, it wouldn't look so easy. There have to be some other separate angles mixed in there. It does make sense. The issue is actually trying to figure out how you make lines. How you actually get... The issue is actually trying to figure out what the distance to these points are. But since I know this is 1 for B, this has to be 1 for D. And that's in the negative y direction. And I know that for sure. So I'll make sure this is like RD specifically. But how much it goes up in it change? Well, no, actually, yes. I'm not. I don't. It doesn't look like it changes in the X direction though. That's harder to tell. The other areas are okay, but trying to figure out the X direction is harder than usual, I would say. And I think that's a bit of an issue. Yeah, trying to think about it. This is cooking me right now. But I don't have to get this done until... I don't have to get this done exactly until... Not Wednesday. Until Friday. But even then, I kind of know inherently that I actually need to get this done now. Because I won't have that much time. So, I think for now, I'll end it here. At this point, at this portion. I still need to figure this portion out here. If I can get these two sides here, I will be in a good position. The only issue is actually being able to get this angle here figured out. But if this is 1 and this is 1, if I try to make a triangle between these, the angle must be 45, most likely. Which I already assumed that to be the case anyway, in my head. So I'll look at that later. Alright, thank you everyone for watching, and I hope to see you guys next time. Goodbye.